we have this expression here. Now, within this expression, on the numerator, we have this absolute x squared minus 1. There is no constraint for absolute x squared minus 1. This does not provide any constraint. Okay? And we want to define the domain of the following function. So the absolute x squared minus 1 provides no constraints. Now the square root x plus 1 implies that x plus 1 is greater than or equal to 0, and the 1 over square root x minus 1, x plus 1 implies that root x minus 1, x plus 1 does not equal 0, which implies that x minus 1, x plus 1 does not equal 0, and the root x minus 1, x plus 1 implies that x minus 1, x plus 1 is greater than or equal to 0. Okay. Notice I split this up into two constraints. One was just the entire denominator does not equal 0. The second was this square root forces a different domain constraint, and the inside must be greater than or equal to 0. And I'm just going to treat these completely separately. Completely separately. Okay. Now, thus far, we've only created the problem we must solve in order to compute our domain. So we've simply taken this function and broken it up into what are the parts we must solve for. Now we're going to do each individual part. Now here, this is going to be greater than 0. And you might recognize this as a set of constraints we solved earlier. So if I have x plus 1 greater than or equal to 0, my split point is x equals minus 1. And I'm going to create a chart at minus 1. My function is x plus 1. And I'm going to create my sign chart. Positive, negative. I'm 0 at minus 1, so positive, 0, negative. So minus 1 and forward, that's my line. X is in the interval minus 1 to infinity. So that's one of my constraints. My next constraint is I have that x minus 1, x plus 1 does not equal 0. Well, because this is factored, this implies that x does not equal minus 1, 0, or 1. So we would write this using interval notation as x is in minus infinity to minus 1, union with minus 1 to 0, union with 0 to 1, union with 1 to infinity. And finally, we have our x minus 1, x plus 1 greater than or equal to 0. My split points are minus 1, 0, 1. Minus 1, 0, 1. My functions are x minus 1, x plus 1. And I'm 0 at each of these points. I'm not undefined at any of them. Now, x minus 1 is positive, then negative, then negative, then negative. Positive, positive, negative, negative. Positive, 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 negative. Completing the sign chart, we do our sign multiplication. And I'm equal to 0 on these points. Now, I want to know when I'm greater than or equal to 0. So include here up to here, include here and positive. So x is in minus 1, including minus 1 to 0, union with 1 to infinity. Now, we have our three constraints. we're now going to combine them. And remember, the way I like to combine them is I will simply draw 3 number lines. And on these 3 number lines, I have -1 to infinity. And then I have negative infinity, not -1, not 0. Oh, not 1. So this is 0, 1. And then I have -1 to 0, 1 to infinity. To determine what is in the intersection all 3, I mark down my key points, or the points at which any of the lines change. And I want to be in all 3. So I'm not in all 3 below -1. At -1, I'm not in all 3. Once I'm above -1, I am in all 3. I'm in all 3 until I get to 0, and I'm not in all 3 at 0. So I include that. Then, after 0, I'm not in all 3. And when I get to 1, I'm not in all 3. But at 1 and after 1, I am in all 3. And now I simply write out this resulting line, which is x is in the interval -1 to 0, non-inclusive, union with 1 to infinity. And this is my domain. And the domain can also be written in set builder notation as x is the element of the real numbers, such that -1 is less than x, which is less than 0, or x is greater than 1. As a suggested exercise, I encourage you to work through these. Now, the first 3 are relatively straightforward. But then the last 2 are a little bit more complicated. The third one, you're going to have to probably use your quadratic formula. But the fourth and the fifth, we're going to have to break it up into cases because of the absolute value sign. If you struggle with this, I highly, highly, highly encourage you go back up to our interval questions and work through those. We're now going to talk about functions, well-known and well-used functions. Now, these include polynomials, square root functions, exponential functions, trigonometric functions, and logarithmic functions. Now, there are many functions we are going to explore that were not explored in functions. Now, these functions that we're going to explore are called hyperbolic, trigonometric functions. Now, these functions are similar to the trigonometric functions in their motivation, and we're going to discuss that later in your calculus classes, depending on which calculus classes you take. For now, we will complete a brief review of polynomial, root functions, exponentials, trigonometrics, and logarithms.